So here we are, the last chapter of the book for this course, Artificial Intelligence and Automation. So artificial intelligence, or AI, has been around for more than 60 years. And I think in that time, it's affected our daily lives now, both at home and in the business. And so with artificial intelligence, we have to ask yourself, how does a computer become intelligent? What types of careers might be available? What do we need to be successful? These are some of the things that we're going to go after in this short conversation. So organizations are developing new technologies, and many of them are using artificial intelligence and expert systems, so to speak. And so as companies become more automated through the use of AI and expert systems, they have to strategically plan for the potential impact in the future in terms of infrastructure on premises, in terms of privacy, etc. And so organizations today, I think, are relying on machines to learn from processes and gain better outcomes, right? And as a result, even robots are becoming more interactive in the business. I see this at my local grocery store. It's checking the stocked shelves going up and down the aisle because new applications are being introduced at a rapid pace. And so I really think it's kind of exciting. Now, these are the objectives. You're welcome to pause and review them in this short conversation. So, an overview of artificial intelligence. AI involves computers with the ability to mimic or duplicate some of the functions of the human brain. That's pretty cool. There was Watson, right? A supercomputer developed by IBM early on with AI capabilities. In fact, Watson defeated 2 Jeopardy champions using natural language processing. I think that is pretty cool. Oh, I think I did have, there we go. I thought I had a slide on that, and there you go. This is a little bit about Watson, and you could go and continue your own research. Very interesting. Now, artificial intelligence systems include people, process, procedures, hardware, software, data, and knowledge needed to develop those systems and machines, because we want them to get to a point where they can simulate human intelligence processes, learning, reasoning, and even self-correction. So AI is, however, a complex interdisciplinary field, as you can imagine, if it's going to mimic humans, right? So you would expect biology, you would expect computer science, linguistics, mathematics, neuroscience, philosophy, and even psychology along the way. I think that's very interesting. So the nature of intelligence is described by the Turing test. And the Turing test attempts to determine whether a computer can successfully impersonate a human, right? And no computer yet, to my knowledge, has yet passed the Turing test. And so I think that's worth tracking and following over the years as you go, because we're getting close. Now, the nature of intelligence, right? The Turing test is again that standard that we're looking for. And so what is intelligent behavior, right? How do we handle complex situations or solve problems when important information might be missing, right? How do we determine what is important and react quickly and, just as importantly, correctly, right? What about visual images? How are we going to understand those, right? Can the machine be creative and imaginative? And will it use, how does it apply heuristics? Heuristics is a term that basically means a rule of thumb. Is it going to apply rules of thumb, for example? So these are all very interesting considerations in this process. Now, expert systems, which is also part of this conversation, are where the precursor of the modern AI systems, right? These were decision-making computer systems in artificial intelligence. And they were designed with the most advanced and reliable approach to solving complex problems. But they work in a specific domain. That really is what makes them an expert system. Here is a picture of expert systems analyzing complex problems, deliver reliable solutions. Okay, just to point that out. Now, there are characteristics of expert systems listed here. Highly effective, understandable, they're reliable, right? They're repeatable, they're standardized, high level of quality. And the components of that expert system would require then a knowledge base. You would need a development engine, an inference engine, right? So you're making inferences about the information that you've received. We do as human beings. Maybe an approach to explanation and an approach to knowledge, further knowledge acquisition, and then a user interface along the way. I think. And so these are, we kind of jumped ahead, but these are the components of what would make up a great expert system. Now, participants in developing and using expert systems. So besides everybody else that we already mentioned, you would want to define a domain expert as defined here. You'd want to understand who a knowledge engineer is. That's the person with training or a lot of experience in design and dev of an expert system. And you would want to further define knowledge transfer, right? This is that person or group that's going to use or benefit from the expert system. Maybe like Alexa, right? What about vision systems, right? Vision systems involve that hardware, software that allows computers to manipulate visual images and pictures. Augmented reality, or AR, is just a type of vision system that is widely used for fun, but also in the medical field. They are using this for training and for actual operation. There are other AI uses as well. Genetic algorithms, right? This is an approach to problem solving based on evolution, right? And the concept of survival of the fittest as a problem solving strategy. There's the intelligent agent that we want to define, right? These are programs and the knowledge base used to perform a specific task. Like a robot or a bot. We also have artificial neural networks, right? That this is a computer system that can recognize and act on patterns or trends that it detects in large sets of data, like the human brain. At work, we use a risk assessment engine to recognize and act on these patterns of large sets of data to stop transactions and to allow us to further analyze them that it questions along the way. There is, and this is a picture of it, of a neural network process from training through results. Kind of neat. More on that in the book. I'm just trying to do a high-level review of artificial intelligence and expert systems. Now, what about employment? There is a wide range of roles and growing, right? Automation sometimes creates a fear of job loss, but if we're ready for the new skills that are required, we don't have to worry about this. So the growth of AI can actually create, they say, up to maybe 60 million new jobs by 2022 and growing beyond that as well. There are many options. A data scientist, there are entire degrees based on data scientists, machine learning engineer, software developer, robotics engineer, business intelligence and AI research scientist. I did put more on artificial intelligence in the Moodle link as well. Now I wanted to touch on some things. So at Dartmouth College, John McCarthy, he proposed the term AI, or artificial intelligence. Also, I want you to realize that a perceptive system approximates the way a person sees, hears, and feels objects. And that AI research is focused on developing machines with the ability to learn from the experiences and apply knowledge and handle complex situations. All of this is considered intelligent behavior. And also I'd like to point out that an inference engine is part of that expert system that seeks information and relationships from the knowledge base and provides answers and predictions. That's an inference engine. Now, I would also like to point out that machine and natural language, an understanding of that. So machine learning is the ability of a computer to learn without having the programmer change the software, right? So this involves the computer carrying out tasks based on inputs and a set of instructions. But natural language processing is a function of machine learning. We use natural language processing every day without realizing we're training the machine to provide better service along the way. This is a machine learning type comparison. There's supervised, unsupervised, reinforced, and semi-supervised. So it's covered in the book. You can pause here and just review this machine learning type comparison. Now there's across the industries, machine learning is used to do a lot of functions, including logistics, insurance, and healthcare as well. And the natural language processing involves the computer understanding and analyzing and manipulating the natural languages for processing of information. Each time a search is entered, for example, the search engine must interpret what the user is looking for and return the relevant results along the way. So that's pretty exciting. Now, online translators have to be trained, if you're going to use those, in more than just word-to-word translations. Grammar and rules and punctuation can make a difference on how a sentence is read. We all see that on joke t-shirts. It depends where you put the comma, right? And so the machine has to learn that as well. There's also a brain-computer interface. This interacts with the human's neural structure, the brain, right? And translates the information, like our thoughts, into activity or actions. The medical field and DARPA, the Defense Advanced Research Projects Agency, are using this with transplant limbs and things of that nature. I think I posted a neural networks link too as well on Moodle. Now, back to the quiz options, right? Remember, Arthur Samuel defined the term machine learning as the ability of a computer to learn without being explicitly programmed, right? I think that's exciting. That a digital currency such as Bitcoin that's used for financial transactions is called a cryptocurrency. That supervised is a type of machine learning that involves using labeled data set and examples to produce an output. And that deep learning allows the programs to grow and learn from the many examples provided by the users, either spoken or typed. That's absolutely true. So there's more in the remaining slides on robotics, industrial robots, etc., industry applications, and what's next. I'm going to leave that to your own reading here. Just realize that our Cartesian robots do not take up large amounts of space and move in a circular motion, and that articulated robot is made to function like an arm. Okay, thank you guys.